My name is Malam Buhari Musa Yusuf, and I will be presenting part of my postgraduate diploma in education teaching practice with you today, okay? So from what we have discussed earlier on, here with me are some of my supervisors with me that they have come to supervise the teaching that I've been doing with you previously, okay? So here are my profile on the board. You have already been familiar with me as the teacher teaching you part of the teaching practice in this school. So you can see this is my name, this is my registration number, and the school I'm carrying out the postgraduate program is from F.C.E. Zaria. And this school is GSS Kaosinio, Government Secondary School Kaosinio. So my subject is chemistry. And the topic that we're going to do is hydrocarbons, okay? Yes. So what do you understand by hydrocarbons? Can someone tell us his understanding of hydrocarbons? Yes? Stand up, Fadila.
Hydrocarbons are organic compounds that compose only two elements, hydrogen and carbon.
Clap for her, excellent. Hydrocarbons are organic compound that is made up of carbon and hydrogen only. Are we together? You have said the perfect definition or a very good definition of what hydrocarbon is all about, okay? So, a compound, organic compound, made up of or consists of carbon and hydrogen, and it is represented by a formula which is CXHY. CXH what? Y. But the way you represent the formula is to write the C subscript X, H subscript Y. You are not expected to write it as CXHY like this. It is wrong way, okay? So you can represent it using this molecular formula as CXHY. Are you following? That is the expression or representation of hydrocarbons. Are we together? Now these hydrocarbons come from a source. There is a source where we can find hydrocarbons. It comes from usually crude oil. Are we together? Crude oil, we are all familiar with crude oil, okay? What is crude oil? Because we've been hearing of crude oil, yes?
It's like raw oil that you are calling it as the crown of the
Below.
It's like raw materials for making all this kind of oil, petroleum.
Very good. Excellent. Sit down. Crude oil consists or composed of complex mixture of different products, like the petrol that he has said, like the alkane. Are we together? Yes. All the members of the hydrocarbons, like gases, all they are crude oil. Are we together? Gases that you've been hearing about, they are what? They are crude oil. Kerosene is part of the crude oil. Diesel, excellent, diesel.
Bitumen.
What again?
Bitumen.
Bitumen. Who can tell us more? Petroleum. What again?
Diesel.
Diesel. All these are what? Are crude oil. Are we together? So we can find hydrocarbons from these sources. Are we together?
Yes.
Now, hydrocarbons is broadly divided into various forms. There are many types of hydrocarbons. So we're going to look into how these can be classified. This can broadly be divided into two groups. We have what we call aliphatic hydrocarbons. Say it.
Aliphatic hydrocarbons.
And we have what we call aromatic hydrocarbons. Okay? Aromatic what? Hydrocarbons. These are the classification. The two major classification or classes of hydrocarbons is divided into aliphatic and what? And aromatic. Are we together?
Yes.
Now, this aliphatic is furthermore divided into two groups. Further divided into how many groups? Two groups. We have what we call acyclic aliphatic and cyclic aliphatic. Are you following? And this one are majorly benzene. The more classical example of aromatic hydrocarbons are what? Benzene. Okay? Benzene. It is a ring form structure of hydrocarbons. We know ring, right? Zobe. Are we together? So it is usually in a ring form. That is the aromatic hydrocarbons. Are you following?
Yes, sir.
Are you understanding?
Yes.
Alright. Now, acyclic simply means representation of the hydrocarbons. The carbon chain of those hydrocarbons are in either straight form or in a branch form. Are we together? Usually hydrocarbons are having the carbon have the ability to catenate. That means carbon has ability to form bonding with another either carbon or other element. So it will have a complex joined structure of a molecule that can either be stretching or can be in a branch form. Are we together? Are you following? So this, like I've told you, it can be in a straight form or in a branch form. Are we together? We are going to look at the branches or the types of them so that we can be able to know what are they all about. Are we together? Alright. For example, this we have three groups of this one. We have the what we call the alkane, alkene, and what? And what? Alkynes. Are we following?
Yes.
And for this ones, this is the same thing as this acyclic, but usually are in form of a ring form. Are we together? Yes. But the form of the way in which this one differs from this is not the same thing. Are we together? This benzene follow the families of the members of the what? Aromatic hydrocarbons. They have aroma. That means they have a nice smell. They have what? Nice smell, fragrance. Most of the perfumes that we have been hearing about, they used to come from what? From this benzene. Are we together? And some of the organic compounds. Are we together? Because of their ability to form a nice fragrance. Are we together? Alright. Now, from these three members of the acyclic hydrocarbons, these alkane, alkene, and alkynes usually have members, and then it can be represented by a formula. Are we together? Let us quickly look into the formula in which they can represent. Alkanes carry on a molecular formula of CnH2n plus 2. Are we together? Then for the alkene, it has this, which is CnH2n. And for the alkynes, it has a molecular formula of CnH2n minus 2. These are the molecular formula, okay? From this molecular formula, you can derive the members of the families of the series, because their behaviors of the members used to be the same. Are we together? Mostly about the same behaviors. The patterns of their structure, the way you can draw their representation of the structural formula used to be the same. And using these molecular formulas, you can be deriving the members from one to any numbers of the homologous series you want to obtain. Are you following? Okay, whereby C is a carbon atom, N is an integer, meaning it's a number. Are you following? N is what? Integers. That means it's a number. And then these are what? Figures or numbers. So from here, you look into the blackboard. From the alkane series, you can derive the molecular formulas of the families, and then you can be drawing their structure. Are you following? Take number 1. Let us assume that n is equals to 1 for the first one, to derive the first member. Okay? Wherever you see n, you represent it with 1. Are you following? So in this one, substituting n with the numbers, you obtain that C, we said that n is 1, right? 1, H, 2, where you have the n, you will now multiply it by the number. 2 times 1, right? Then plus 2. Are you following? Yes. In mathematics, the conventional way to write any alphabet with 1, you don't need to write the 1. Okay? You now leave it silent. C, 2 times 1. 2 plus 1. So you can see the first member is CH4, okay? Which is what? Methane. Are you following? Yes. Then the second member, let us derive for H, 2 times what? Plus what? Then C2, 2 times 2 what? 4 plus 2 what? 6. Are we together? Yes. This is the second member, which is what? Ethane. Which is what? Ethane. Very good. Then the number 3, C3, H, 2 times 3 is what? 2 times 3 is what? 6. Plus 2 is what? 8. So you can see that the number 3 is what? Propane. And then the molecular formula is what? C3H what? 8. That is for the propane. The molecular formula is C3H what? 8. The molecular formula for ethane, C what? C2H. C2H what? H6. Are we together? Yes. Then the molecular formula of the first member is what? CH4. Which CH4, right? Yes. Okay. Who can tell me the molecular formula for the next member, which is the number 4? Can someone tell me the molecular formula of the number 4 member? C what? What should it be? Yes? Come and write it please for us. Clap for her before coming. Tell us your name. Zainab what? Very good. Write it on the board. Clap for her. C for H word. You can see that the successive member, that means the next member is increased by 2 hydrogen atom and 1 carbon atom. Isn't it? Sometimes you don't need to do the calculations. If the first member is CH4, the second member increase the carbon by 1. And then the next member carbon is increased by 1. But from the difference between the first member and the hydrogen is 2 hydrogen. Are we together? Yes. The first one CH4, the second one CH what? The third one CH what? The fourth one C what? Then the fifth one should be what? C what? H what? H what? Very good. So from the members you can see that this is methane, this is ethane, this is propane, this is butane, this is pentane. Are we following? Yes. Are we together? Yes. Now, from this molecular formula, you can also draw the structural formula because showing that this is how the structure goes on. Are we together, class? Yes. Gentlemen. Very good. For the first one, for the methane, carbon should always be the central atom. Okay? If carbon is the central atom, hydrogen is bonded or covalently bonded with the carbon. How many hydrogen do we have? So you can see here is your hydrogen, here is another hydrogen, here is another hydrogen, here is another hydrogen. This is the structural formula. Hello? Hi. Do we understand? Yes. Do you people understand what I'm expressing to you? Yes. So you can see the structural formula for the methane is C with this structure, okay? And for the methane, for the ethane, let us look together because I want you people to develop the remaining one as an assignment. For the second one, we have C2H what? C2H what? 6. So now how many hydrogen should be? 6. Bonded to the structural, to the skeletal system of it, okay? Yes. So hydrogen should be here, hydrogen should be here, hydrogen here, 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 here. Let us come together. 1, 2, 3, 4, 5, 6. Very good. Can someone draw the number 3, the propane on, so that we can evaluate? Okay. Stand up quickly, come and write it, and draw the structure for the propane for us here. Clap for her. Draw the structural formula for it here. Okay, is it complete, class? Okay, clap for her, she have tried for making this step. Okay? Can someone come and complete the structure because it's not complete? Okay, sorry, this one, boys this time around. Ladies have been performing excellent. I want to see the performance of the boys in the class. What's your name? Okay, Abdulrazak. So complete the structure, use this one. Or this one, completely. Okay, class, can you look, go and sit down, thank you very much. Can you look at the structure you have drawn now? Can someone observe, is it correct? No. It's not correct, right? Yes. Okay. Are you convinced that it's not correct? Yes. Okay, so please, who can come and draw the structure? You, that lady, come. Let me clean this part for you, so that you can draw the structure very well. Here, use this place. What's your name? Zainab, use this side here so that it will be clearly written. But you have tried, actually. Okay, class, is it correct? Yes. Clap for her, please. Thank you very much. So we count the hydrogen before we now conclude. 1, 2, 3, 4, 5, 6, 7, 8. It's correct, right? Yes. And the carbon is 3, is complete, right? Yes. So clap for yourself. Okay, with this introduction of the hydrocarbons, we have come to the end of the class, and I would like to evaluate the class by you people to ask me if you have any question with regard to what I've expressed to you, if there's any question that is not clear to you. You can ask questions with regard to what we have discussed. Any question? Okay.
Sir, please, I want to ask for the name of that one, the last one.
For the
Name of the last one that you said.
this one?
Yes.
Pentane. Okay? So the members of the series from the 1 to 10, we have methane, ethane, propane, butane, pentane, hexane, heptane, octane, nonane, and what? And what? Decane. Alright? So, and from number 5, I will ask you people when you go home, I'm expecting you to submit this tomorrow. Draft the molecular formula for the from number 6 to 10, and then with their structural formula, okay? So that it will enable us to move into the next subtopic. Are we together? So that we can move to the next members of the alkene series. Are we together?
Yes.
So thank you very much. I'm happy. My humble supervisors, I don't know if there's anything that you're going to say.
Presenter, you really try.
Okay, thank you.
Job well done.
All right.
We appreciate. Keep on.
Thank you very
And
much, sir.
students, keep on. I think you are enjoying your teaching. You try very well. Keep on and follow your plan. You will be a leader tomorrow by God's grace.